Finding an angle of rotation. All right, so we're given a regular hexagon, is shown below. Suppose that the hexagon is rotated clockwise about its center. So when we say rotated, we're literally talking about turning something like this. And when it's about the center, so think of it like a steering wheel, that we're just turning like this. So this center point isn't moving. It's all the other points that are moving around. And we want to turn it so that this point moves to O. And we're going counterclockwise, so it means we're going this direction. So you have to pay attention which direction is axing. Counterclockwise means the wrong way on a clock, so go backwards. And we want to move it from M to O. So it moves 1, 2, 3, 4 positions. So we know it moves 4 positions. But how do we know? Because it says how many degrees does the hexagon rotate? Well, how do we know that? Well, if we think about a regular circle, and I'm not terribly good at drawing circles on here, but if I draw a regular circle here, so I went all the way around, this is 360 degrees. We can think of this the same way. We're rotating. Think of a steering wheel. It's round, or round-ish. So when I rotate, I'm rotating around a circle. That's what we can kind of think about. So if I have a hexagon, I know that there's 6 different spots. So I have to divide that circle up into 6. So I want to take 360 and divide by 6. And I get 6, 0. So I get 60 degrees. So each rotation means that I rotated 60 degrees. So I just take 6 and I multiply by 4. Sorry, 60. And I multiply by 4. And I get 240 degrees. So if we scroll down here, that's exactly what we got here. So they're showing you the same thing. Each one of these turns is a 60-degree turn. So we need to pay attention to a couple of things. Number one, we need to pay attention to which letter we're starting with, which letter we're ending on. So which vertice is turning to which other vertice. Which direction are you going, clockwise or counterclockwise? That changes things. So if we went clockwise on this one, we would have only gone 2 turns. So we have to pay attention to which way we're turning, and then how many sides does the shape have. All right, so let's go ahead and get started. Okay, so the hands of a clock below is pointing at 4. Suppose that the hand moves clockwise, so the normal way, until it's pointing at 11. So now we have this pointing up here at 11 like this. So it went from 4 all the way around here to 11. So it moved 1, 2, 3, 4, 5, 6, 7 spaces. So we know it moves 7 spaces. But we need to know how many spaces there are. Well, if you count in between, so we have 7, and I'm going to change the color here just so you know I'm not. So 7, 8, 9, 10, 11, 12, which we know there's 12 spots on the clock. I just want to make sure that you see that. There's 12 spaces that it can move. So remember, this is definitely a circle. So we can take the 360 and divide by 12. That will tell us how many degrees each one of these moves is. So if we divide by 12, we get 3, because 12 divides into 36 3 times, and then I have 0 on the end. So I know it's 30 degrees each. Yes, you can use a calculator for that if you need to. I just did that kind of mental math. Hey, knowing your times tables does help this move a little quicker, and it makes things a little less frustrating if you know your simple times tables like this, so you don't have to pull a calculator out every time. So anyway, just my little lecture on knowing your times tables. All right, so we know we moved 7 of these spots, and each one of these spots is 30 degrees. So we're going to multiply by 30, and we'll get, let's see, 7 times 3 is 21, and then we put a 0 on the end. So 210 degrees. So let's go, whoops, 210, and check. We got our point. All right, clear, next. Okay, so this one says, a regular octagon is shown below. Suppose the octagon is rotated clockwise about its center, so we need to pay attention to clockwise. We also need to pay attention to octagon. We'll come back to that. About its center, so the vertex X lands on V. So remember, we're not going the shortest distance. It said clockwise. We're going this way, like that. So how many degrees does the octagon rotate? So we have 1, 2, 3, 4, 5, 6. We're rotating around 6 different spots. And octagon means that it has 8 sides. If you didn't know that, you could just count the number of sides. So we're going to take 360. We're going to divide by 8 this time so that we know how many degrees each one of these rotations or each one of these spots are. So let's see, we end up with 4 because it goes in 32, and then let's see, 40. So we should end up with 45. I'm going to confirm it really quick just because you don't want to have something silly like that throw off all your calculations. So yes, it is 35 or 45. So each one of those is 45 degrees. I know I moved 6 of them, so I'm going to multiply 6 and 45. So I don't like looking at it horizontally. I like looking at it vertically, so I'm going to change this up. So I have 30, 24, 25, 26, 27, so 270 degrees. So 270. Check. All right, one more. A circular dial has 10 equally spaced points as shown. So it's telling us 10 spaces. We know that. So we're going to take 360 and divide by 10. We'll get there in just a moment. So I'm already writing that part out because I know what I'm going to divide by. Point A is at the top of the dial. Suppose the dial is turned clockwise until H is on top. So we're going to turn H so that H is now on top. And it said counterclockwise. So if you turn this way, it's a shorter distance, but they said counter. I need to go this way because that's backwards on the clock, counterclockwise. All right, so I'm going to move 1, 2, 3, 4, 5, 6, 7 spaces. So I know I'm moving 7 spaces. And I know I need to divide by 10 because there's 10 equally spaced points. So if I divide by 10, which is super easy, I can just cross out the zeros here. I'm left with 36 divided by 1, which is just 36. So each space is 36 degrees. I moved 7 of them, so I need to multiply by 36. Again, I don't like looking at it horizontally, so I'm going to change it this way. So I get 42. 21 plus 4 is 25. All right. So 252. Check. Yay, we finished that one.